Hello viewers, we'll introduce to the line integral. So let a position vector that's r of t equal to x of t I and y of t j and z of t k, where I j k are the unit vectors along x-axis, y-axis and z-axis. Since the vector is defined by single parameter, so this is a curve, and this curve is noted by c, so this is the c curve. So you can say that the p1 point and p2 point are lies on this curve c. Let a of x y z be a vector equal to a1 x y z I plus a2 x y z z plus a3 x y z k. This is a vector valued function, and there are three variables x y z, so this is the surface. Now let us consider an integral of tangential component. That means integral of tangential component of a vector. So this is the integral of tangential component of a from p1 point to p2 point. We can write it, that is the ca dot dr. This is the line integral. So I have a question there. What represent it? Firstly, we will see that when a vector is defined on x, y, z is the coefficient of r in the form, then it is surface. But x of t is a function of t only. So here x of t, that means this a1 is a function of t only. At that time it is a curve. What's the curve? That means this is the curve. This is the curve which is defined. And this curve must be lies on the surface. So this curve is produced for the domain. That means this is the domain. So this is the output curve of the surface for the curve C. So we will see that the integral means the area of this region. For that, so I say point on C curves and the position vector of it, that is Ri of t. I, that means 1 2 3 4 5 6, anything. So any vector position is defined by Ri, and any vector position on the surface and on the curve, then ai t. The angle between the two vectors is theta. Now dri by dt of t is the vector, and the direction of it to the tangent, and the angle between the two vectors is differed by pi by 2 That means pi by 2 minus theta is the angle between them, or theta minus pi by 2 is the angle between, because r of t and dr by dt of t are perpendicular to each other. These two are the space curve. Now a dot dr would be written as this form: c a vector and dr dt and this would be written as a Riemann integral. The limit del t tends to 0 and the summation I equal to 1 to n and ai dri by dt, that means ddt of ri cos of pi by 2 minus theta and del t. We can rearrange it as a visual shape. That means limit del t tends to 0, summation I equal to 1 to n and ai sine of theta d dt of ri and dl. This represents the perpendicular distance, that means this distance, perpendicular distance, and the cos theta ai cos theta, that means this distance or length, and ai sin theta means the perpendicular length, and this is the infinitesimal strips width. Now we'll see that which is infinitesimal strips width. So it is clear that this is the direction of r dash, because the derivatives of r. So this is the height, or we can say that this represent the magnitude of ai along the vertical line of ri. So this is the vertical line. So that means the height of infinitesimal strips is this is. Now we will see this is the width. If we write that's the r dot what dr dt, then we can write this is dx dt whole square plus dy dt whole square plus dz dt whole square and square. In two-dimensional case, it is easy to say that is x and y, this is the curve, and this is the del s, that means arc length, small arc length, and this is the perpendicular line, and this is the vertical to this perpendicular line. So this is called del x and this is called del y. In Pythagoras theorem, that's the del s equal to root over del x square plus del y square. So in two-dimensional case, ds dt equal to root over dx dt whole square plus dy dt whole square. So in general case, del of si equal to dri dt and del. So it represents the width of infinitesimal strips. So multiple of this term and this term represent the area of the infinitesimal strips, because the strips width is this and the height is, so the multiplication of these two terms that represent the area of this infinitesimal. So summation of these represent the area of this region. So you can say that the line integral represent this area. If we see example, there are, if the line integral represent the area of fence, that means some stick are put on this line and this stick touch on the surface and cut by this surface. Then there are a produce a curve on the top of this stick, the joining of the top of this stick. So this curve and this curve and bounded by P1 and P2. So this is the bounded area, and this area is defined by the line integral. Thanks.